I'm going to be discussing my research under the guidance of Dr. King in the Computer Science Department at Bucknell in collaboration with Dr. Troiani at Geisinger. So, to summarize my research in this brief 3-minute overview, my work focuses on improving and making publicly available data visualization tools used by eye tracking researchers. This research is focused on autism spectrum disorder, or ASD, in collaboration with Geisinger's autism researchers. I'll show the key zoomed in sections of my poster while using my cursor to highlight things along the way. So, the CDC estimates that around 2% or so of children in the US have ASD. And unlike what usually happens, if these children were diagnosed with it at an earlier age, they could undergo treatment to improve their cognitive development during their formative years. Now, ASD researchers can often understand a child's perception of the world through what they look at. The researchers use computer hardware to track where a child is looking on an image shown on a screen that has a handful of objects like you can see right here in Figure 1a. Now, children without ASD tend to focus on social objects, but children with ASD really don't have a preference of social versus non-social. Current eye tracking data produces heat maps, and you can see that the warmer colors represent where participants tended to focus on, and looks like children without ASD tended to focus on, faces and food. So now my work, currently being improved and finalized, is ultimately going to make the currently vast and unfortunately privatized eye tracking analysis and visualization software public to the wider research community with an open source app that I designed from scratch. This is the user interface right here. Also in the app, I implemented an improved algorithm to summarize where participants looked by identifying clusters, these colored globules right here. And I filtered out any random eye movements, and the machine learning was used to identify objects in the image to label what each object is, as shown here, and whether it's social or non-social. My next step is to refine this clustering algorithm so researchers only have to specify 1 instead of 2 parameters in the app to produce distinct, meaningful clusters in combination with the machine learning functionality to label and classify specific areas of interest within an image. On top of that, I'm working on implementing functionality to allow researchers to see animated plots that summarize all the eye tracking data across multiple, not just one, participants over the entire duration of the study. Currently used heat maps lose this important temporal dimension that gives researchers a detailed clinical story regarding the order in and duration for each participants look at areas of interest on an image. And that's a wrap. Thanks for listening, everyone, and I can't wait to hear your questions at the Q&A.